This is part 4 of the tutorial series on making a basic experiment in TUX. Part 3 added scripts to manipulate our Unity scene and measured our dependent variables. In this section, we'll work on accepting user input, adding a blocked variable, and configuring randomization. When we ended the last section, we were writing our match size variable, but the user still couldn't adjust the size. Let's add that in now. So we have this match size being written in that's affecting the local scale. So we have to allow the user to adjust the local scale of this object. So let's go back to the scene, and they're going to be adjusting this match object here. So let's add a new script to it. So we'll add a component and we'll call it matcher. And I'll hit enter and then create an add. And it should appear right here. So we'll open that up in Rider. Okay, so this will just be a normal Unity script that will then control from our trial script. So in the update method, we want to listen for user input. And so we'll say if input dot get key down key code up arrow. So if they're hitting the up arrow, we want it to increase size, which we'll write that method in a second. If input dot get key down arrow, then we want to decrease size. But we only want to let them adjust the size during the main coroutine of the trial. And so we don't want to allow them to do it at any time. So we're going to put a little flag in here, a boolean, to just turn on and off when we want to allow them to adjust the size. So we'll say bool allow adjustment, and we'll start it off as being false. And then here we'll say if allow adjustment, then we'll listen to those things. Okay, so now we have to write increase size and decrease size. So we want to be able to adjust the speed of increasing and decreasing to make it more comfortable for the users. And we want to be able to do that in the editor. So we'll add a public float resize speed. And this we can just adjust when we're testing. And we'll just set it to 1 to start off with. So I'm going to have Rider create this method for me. And now to increase the size, we're going to adjust the local scale of this object. So we'll say transform local scale plus equals our speed times the time since the last frame fired, which is time.delta time. So if a frame took a little extra time to render, then this will move it a little further, increase a little further. So that will make the appearance of being of consistent speed. And we have to put this inside of a vector. So I'm going to turn this into a float variable called amount. And then that way we can just write amount 3 times here. Okay. So it's just adding this amount onto its existing local scale. And then we need the same thing for decrease size. But this time, instead of adding it, we'll just subtract it. Okay. Perfect. So now if we're allowing adjustment and they push the up arrow, we'll increase its size. And if we're allowing adjustment and we push the down arrow, it will decrease its size. And if we don't allow adjustment, it'll just skip through and nothing will happen. Great, so let's just make sure that's working. And I'm going to make allow adjustment public so we can adjust it from another script, or from the inspector if we want. So I'm going to go back to Unity, and on the match object here, we now have the matcher script. And just for testing purposes here, we'll allow adjustment, and I'm going to hit play. Okay, and I'm just going to test it out. I'm going to hit the up arrow, and it's increasing, but it's only increasing once every time I push the button. And there's a good reason for that, but it is working. If it goes down, it'll go down. If it goes up, it'll go up. And let's try increasing the speed, and we'll see if that works. So now I've set the speed 20 times what it was before, and now it's increasing quite a bit. So let's just make it more fluid so we can hold down the plus or minus sign to get it to work. So we'll go back here, and if we look here, it says get key down. And so that's only when the key is pressed down the first time. So if we just say get key, then it will check every frame, whether it's down or not. So I'll save that, I'll head back. I'll start play mode again. And now I'm going to hold down the button, and perfect. Much more smooth. And so we can adjust the speed if we like, but this looks pretty good. I feel like you could get pretty accurate with this. So we're going to turn off allow adjustment now that we're done testing. I'm going to save the scene. Oh, I have to do that outside of play mode. Save the scene. And now we have to be able to control this allow adjustment in our trial script. So in order for our trial script to know about it, we have to reference it in our tutorial experiment runner, just like we referenced all these other objects. So I'll open that script up in Writer, and I'll add a new field called public matcher. Okay, and then I'll go over to the trial script now. And while we're waiting for the participant response, we're going to say runner dot matcher dot allow adjustment equals true. So now we're allowing it to be adjusted while we're waiting for a participant to respond. And then after it's done waiting, we'll turn that off. Equals false. Okay, so just to reiterate, it's going to wait for a participant response, and the response we're looking for is to confirm their answer with the return key. And while it's waiting for the return key, it's going to allow them to adjust the size of their matched object. And then once it's gotten the response for that trial, it's going to set it to false. This loop will end, and then it'll turn off the adjustment. So let's just make sure that works. Okay, so I press play. I'm going to start off with debug mode and null reference exception. That's because we haven't linked the tutorial experiment runner object. See how this is empty here. So we just have to drag the matched object in there. That looks good. Okay, I'll go back to the participants view. Okay, so we're in trial 1 here, and I can move the object size to match it. And then once I think I've got it matched, I'll hit return. And now we're on the next trial. So I'll try to match it. Try to match it. Great, and now I'm going to do one really wrong. just to see what that looks like. I'm going to go back over to the display 2, and if we look in here on the match size, I'll make it a little bigger. So if we looked at the match size, we were pretty close on the first 3 trials, and then the one where I tried to purposely be really off, it was really off. So it looks like that's all working now. And so later on when we're doing our data analysis, we can just find the difference between the actual size and the match size. And so here the size was 2, but our match size was much, much bigger. Great. So now let's start adding some more complicated features into our experiment. Our fundamental experiment is complete now, but we want to add some extra features in. So let's go back to our design object. And we're going to add a new variable. And this time we're going to add a blocked variable. We want to be able to adjust the distance from the camera that the matched object is. So we're going to create an independent variable. And it's going to be a float because it's going to be distance. We'll name it distance. Okay, so 0 is where it is currently. And we'll say we'll move it backwards by 1 meter and then backwards by 2 meters. So we'll add some values, 0, 1, and 2. And now we want this to be blocked together. We want all the trials at one distance to occur together, followed by all the trials at another distance, followed by all the trials at another distance. So I'm going to click this block button to keep these 3 values blocked. And now when we go down to our preview, we can see that now when we look at the block column here, there's 3 blocks. And in each block, the value of distance is the same. So that's exactly what we want. And now we have to add the distance manipulation into our scripts. But because this is a blocked variable, we can't adjust it in our trial script because the trial doesn't really care what block it's in. So now we have to edit our block script because at the beginning of every block we want to adjust the distance but leave it the same for that whole block. So let's open up our block script, and just like before there'll be a kind of a pre-generated file here with a bunch of comments to remind people where to put things. I'm just going to delete those to keep it nice and clean when we're learning here. So again, there's a constructor just like the trial script. And there's a pre-method, pre-coroutine, post-coroutine, and post-method. Notice how there's no main coroutine. For a block, the main coroutine is simply just running the trials in the block. So we can't really overwrite that. We're only going to be using the pre-method and the post-method because we're going to adjust the distance and then we're going to reset it at the end of the block. Okay, and our block script needs access to our tutorial experiment runner. So we're just going to do that cast that we did last time. So we'll say tutorial experiment runner, tutorial runner, and then in our constructor we'll set that. Tutorial runner equals tutorial experiment runner cast of the runner, just like we did in the trial script. So now we have access to all those game objects that we set up in our Unity scene already. And in our pre-method, we're going to get the distance. So we'll say float distance equals, and remember we have to cast it back to a float to remind Unity that that variable is a float variable. So now it's going to look at what this block, what the value of distance is for that block, and then we have to do something with that value. So we'll say matched object. Actually, I think we want to move the stimulus rather than the matched object. So we'll say tutorial runner dot stimulus dot transform dot position equals new vector 3, and we'll keep it as the same position on every coordinate, but we'll move the z position. If we look back here, z will move it away from the camera. If we zoom out a little bit, we can see the camera's here, and our z-axis is going backwards into the scene. So we want to increase our z value to move it back. So we're going to store the position in a variable here. So we'll say vector 3 current position equals its position. So then we'll set its new position to its current position in the x-coordinate, current position in the y-coordinate, and then our new position, which will be distance. I'll save that. Okay, and then we should probably reset it at the end. So we're going to store this current position in a field. So I'm going to use Ryder's refactoring tools here to just turn that into a field. Keep it called current position. So now that just automatically created this variable here, and then set it here. And so now we can access it down here. So we'll say tutorial runner stimulus transform dot position is just equal to current position. And maybe a better name for that would be initial position. So I'll just use Ryder's refactoring again to rename that to initial position. So it gets the position it was before the block, saves it, and then it says, okay, so let's set our new position to the same x-coordinate, the same y-coordinate, and then a new z-coordinate. And then at the end of the trial, we'll set it back to its initial position to reset it. Okay, let's see how that works. So we'll hit play, and we have to hit debug mode again. So we start our trials. Okay, so now we're in block 0, so we should be at distance of 0. So let's double check that's the case. Yep, so they're still lined up. Perfect. So let's advance through a few trials here. And I'm going to look at the console down below to see, okay, now we've started block 1, which is index 1. So that's the second block. And we want to just see if that actually moved it back in the scene. And it looks like, yes, it did. It's now behind the other one. And so we'll go back to the participant view. We'll go through a few more trials until we get to the next block. So now we should be 2 behind. So let's check that's the case. And yep, it jumped back another meter. So that's great. But the problem is our participant can't really see that jump because we're looking at it head on, and we don't really have too many depth cues. So I'm just going to change where the camera is so that it has more of a high view here. So I'm going to, in the editor here, line up kind of where I want the camera to be, like this. And then I'm going to click the camera and go to Game Object, Align with View. That'll just set the camera to be the same position that I'm looking right now. And now we can see the camera preview is the same as my editor window. So let's just, you can see that when I move the editor window, the camera stays there. And so I'll play it again. And now the participant should be able to see a better view. Yeah, and so now we should be able to see it jump back when we get to the next block. Perfect. And now it's further back. And back to start. Great. So we have our block working now. But the blocks are going to always come in the same order. So it's going to start off close, then go backwards. But what if we wanted to randomize that order? So we can go to our design file, and in this section at the top here, we can say block randomization. We can say complete randomization. So that'll just shuffle all the blocks together. So now when we hit play, debug. So now we can see that the size variable, the distance variable here is out of order. So it starts off with distance of 1, then goes to 2, then goes to 0. And if we played the experiment again, we might see a different order. So now we have size 1, distance 2, then 0, then 1. So yeah, it keeps getting randomized. We can preview that randomization in our preview window here. So if we go to preview design, it'll do some random randomization here. Then we can re-randomize just to see how things change from experiment to experiment. Okay, but when we're doing this block randomization, our trials are still in order. So if we look at the design again here, we can see that within each block, the size still goes 1, 2, 3, 1, 2, 3, 1, 2, 3. No matter how many times I re-randomize it, the size is not being randomized. So to randomize the trials within a block, we can go to the design file, and here there's a trial randomization section. So we can pick randomized, and then there's different ways we can do it. So one permutation means it'll shuffle it, but it'll use that same result in each block. Whereas different permutations mean it will re-randomize it for each block, which is what we want. We want it totally randomized. So now if we press play, so now we can see that within each block, the size variable is shuffled, as is the color variable, and basically full randomization. But our distance variables are still blocked together, but those blocks will come in a random order. And let's just see how that works over many experiments. Yep, so we can see all three of these columns are getting shuffled now. Perfect. And now we have a pretty functional experiment. We have a block variable, we have a normal independent variable with a string, we have a normal independent variable for size, we have a couple dependent variables, and some participant variables. So let's put it all together now and run a real run through the experiment. So this time we're going to press play, but we're not going to start it in debug mode. We're going to actually pick a file and a folder. So I'm going to go to my Finder here and pick my desktop folder. And I'm going to create a new folder called results. Okay, and then right down here we can see what the path is. I have a little script where I can copy the path, services, copy path, paste that there. And then file name we'll call result. Make it just bigger so you can see what I'm typing. So we'll call it result1, and we'll store it in that folder I just made. And then my age is 34, I'm male. And then now we'll click Start Experiment, not Debug. Okay, and so we'll go over to what the participant would see now on display 1. Okay, now I have to match. And then when we're done, we should see that our nice results are populated in a nice CSV file. Alright, so it says experiment complete. So I'm going to stop play mode. Now I'm going to head over to my desktop here. And in the results file, we should see results1.csv. So I'll open that up. And here are my results. So we can see the distance, the size, the color, and then the size I picked. So let's insert a new column right here, and we'll just see what the difference in size is. So we'll do the size minus my picked size, and we'll fill that in. And so generally speaking, I was probably about 40 centimeters off, 50 centimeters off maybe. Not too bad. Some of them I was very close. So that concludes the tutorial. I hope it gives enough information to get started, and you can expand it as much as you like from here. And before quitting, I just want to show how to get it working with VR. And so you just go to the Asset Store. So you go to Window, Asset Store, Steam VR. Okay, and then there's a plugin here for Steam VR. Just click on that and go to import, or you might have to download it first, but then import it. Accept all of the options, and then you'll see a new folder appear here, and you're ready to go. You don't have to do anything more than that. The camera will be taken over by the Steam VR functions, and everything else should just work out of the box. So good luck using TUX, and if you find any problems or have any questions, please check out our documentation page, and feel free to submit any bug reports on our GitHub page. Thanks so much for watching, and see you next time.